Statistics and probability.
Hello! Do you know about confidence interval? Let us all watch and listen to this video lesson. Let us have first the competencies. The first is identify the length of confidence interval. Compute the length of confidence interval. Compute for the appropriate sample size using the length of interval. Solve problems involving size determination. Hi Blue. Hello Orange. Let us learn about confidence interval today. I like that. What are we going to do first? Let's start with activity 1. Here is activity 1. Determine the point estimate of the following situation. Note, point estimate is the mean or the proportion where P is equal to X over N. Number 1. Juan surveys a sample of his classmates on how much their weekly allowances are. He was able to get an average of weekly allowances of 250 pesos and a standard deviation of 20 pesos. Number 2. In a plant box consisting of 100 seedlings, 75 seedlings were treated with growth enhancer. How many minutes do they need to answer this? Pause this for a while and try to answer for 5 minutes.
A few moments later.
Welcome back! Do you have your answers? How about you, Blue? I already have my answer, Orange. What is your answer for number 1? My answer is 250. You are correct, Blue. How about number 2? My second answer is 0.75 or 75%. Again, you are correct. Thank you. How about you there? I hope you got both correctly. What are we going to do next, Orange? Let us have the next activity. Here is activity 2. Determine the z-score and t-score of the following confidence level and sample size given. Note, use the z-table and t-table. Number 1. 90% confidence with n equals 23. Number 2, 95 confidence with the sample size of 31. Number 3, 98% confidence with n equals 15. And number 4, 99% confidence with n equals 51. Can you help me, Orange, on this? Yes, I will help you, Blue. And for you there, you will be given 10 minutes to answer. God bless.
A few moments later.
Do you have your answers already? How about you, Blue? I already have my answers, Orange. But I'm not sure with my answers. Can you show us the answers? It's alright, Blue. I'll show the answers one by one. Later, you will discover the use of two activities in our topic about confidence interval. Here are the answers. For number 1, z-score is 1.645, t-score is 1.717. For number 2, the z-score is 1.96, while the t-score is 2.042. For number 3, z-score is 2.33, while t-score is 2.624. And for number 4, z-score is 2.575, and t-score is 2.678. The activities are great, Orange. I am more excited about confidence interval. That's good to hear from you, Blue. How about you there? Are you also excited like Blue? Let us now have the lecture about confidence interval and its length. A confidence interval in statistics refers to the probability that a population parameter will fall between a set of values for a certain proportion of times. Do we have a formula in finding the confidence interval? Yes, Blue. We have here the CI or confidence interval is equal to the point estimate plus minus the product of the critical value and the standard error. Here we have the point estimate is our mu or the population mean. And for our critical value is the critical value of 2 tail z. And for our standard error is the quotient of population standard deviation and the square root of the sample size. So we have here the critical or the confidence interval is equal to the population mean plus minus the critical value of 2 tail z multiplied to the population standard deviation divided by the square root of the sample size. Or we have here our point estimate here is the population proportion. So our confidence interval is P plus minus the critical value of 2 tail z times the square root of P and Q, where Q is 1 minus P all over the sample size. Or if our sample size is less than 30 or the standard deviation is unknown, we use this confidence interval equals mu plus minus the critical value of 2 tail t times the sample standard deviation divided by the square root of sample size. The formula looks like complicated for me, but I will try to understand that, Orange. You can understand it once we will have some examples. How about the length of interval? The length of confidence interval is the difference of the highest value and lowest value of the interval. What is the formula for that? We have here the three different formulas for our L. So the length L is equal to 2 times the critical value of 2 till z times the standard deviation or population standard deviations divided by the square root of our n. Or we can have L or length of our interval is equal to 2 the critical value of z multiplied to the square root of p and q all over the sample size, or the length of our L is equal to 2 times the critical value of 2 till t times the sample standard deviation divided by the square root of the sample size. Are you ready for some examples, Blue? Yes, I am ready, Orange. Before we'll have the examples, Blue, let's have the critical values. Yes, Orange. Here are the critical values for the 2 tail z corresponding to its confidence level. Remember activity 2? Yes, those are the answers for z in activity 2. How about the critical values of t? Use the t-table. The critical value of t is the intersection of the confidence level and the degrees of freedom. I got it, Orange. Let's now have or proceed to examples. Example number 1. Given 90% confidence and n equals 35 when our population standard deviation is 4, find the length of the confidence interval. So with our formula, using our formula, which is L equals 2 times our critical value of our Z, then our standard deviation over the square root of our N. So using our formula, we substitute it to L. So L equals to 1.645. This is 1.645 since our given is 90% confidence level. And then substitute 4 and over square root of 35. So we have here 3.29 because the product of our 2 and 1.645. And then the square root of our 35 is equal to 5.916. So 4 divided by 5.916 is 0.672. So we multiply 3.29 and 0.676. The answer is 2.22. Therefore, the length of our confidence interval for sample number 1 is 2.22. Example number 2. In a box consisting of 250 oranges, 200 are sweets. What is the point estimate? Find the 95% confidence interval for the population proportion P. What is the standard error? And determine the length of interval. For our first question, what is the point estimate? So to get the point estimate, we solve our P. So the formula in getting P is X over our N. So our X is 200 divided by 250. The answer is 0.8. Thus, the point estimate is 0.8. For the second problem, confidence interval. So confidence interval is equal to point estimate plus minus the critical value multiplied by the standard error. So given our P is 0.8 and our Q is 0.2, since P plus Q is 1. So our N is 250 and the critical value is 1.96 because of the confidence interval, which is 95%. So for our CI, using the formula, 0.8 plus minus 1.96, 0.8 times 0.2 divided by 250. So 0.8 times 0.2 is, we have 0.16. And then 0.16 divided by 250, we come up here with 0.00064. And then CI is equal to 0.8 plus minus 1.96. And the square root of the 0.0064 is 0.0253. So we multiply the 1.96 and 0.0253. So our CI is 0.8 plus minus 0.0496. So we subtract 0.8 and 0.0496 and we add 0.8 and 0.0496. So therefore the interval is from 0.7504 to 0.8496. So for letter C, what is the standard error? For our standard error is the square root of PQ all over N. So our 0.8 times 0.2 is 0.6 divided by 250, that's 0.00264, and then square root of 0.0064 is 0.253. So determine the length of the interval. So using our formula, so with a given, so we substitute L equals 2 times 1.96 times the square root of 0.8 times its 0.2, and then all over 250. So our L is equal to 3.92 times 0.0253, which is equal to 0.0992. Other solution is we subtract the interval. Based in our answer in letter B, 0.8496 subtracted by 0.7504, the answer is the same, 0.0992. Therefore, the length of interval is 0.0992. Third example, for n equals 25 and confidence of 95% with population standard deviation is unknown. What is the critical value of t and what is the length of interval if s is 3? So the intersection of confidence level 95% and degrees of freedom 24. So our degrees of freedom is 24 because degrees of freedom is n minus 1. So 25 minus 1 is 24. Based on the t-table, the answer is 2.064. Therefore, the critical value for t, total t is 2.064. For letter B, using the formula L equals 2 to the times the critical value of t, and the S, which is the sample standard deviation over the square root of n. So 2 times 2.064, 3 over square root of 25. Square root of 25 is 5, so that's why we have here 3 over 5. And then 3 over 5 is 0.6. So we have here 4.128, that's the product of 2 and 2.064. So 4.128 times 0.6, we have 2.476. Thus, the length of the interval is 2.4768. I got it, Orange. Are you ready for the third activity? Yes, I am ready, Orange. Here is the third activity. Read the problem below and answer the questions that follow. A CEO of a battery manufacturing company claims that an average battery lasts 360 days and a standard deviation of 25 days. A researcher randomly selects 40 batteries for testing. A. What is the point estimate? And B. What is the length of interval at 95% confidence level? Number 2. The Kabankala National High School has 155 grade 11 male students. Among them, 110 grade 11 male students said yes to the no haircut policy. A. What is the point estimate? And B. What is the length of the interval at 98% confidence level? You will be given 10 minutes to answer.
A few moments later.
Welcome back! Are you done answering? How about you, Blue? I am done, Orange. My answer for number 1 for A is 360. For B is 15.495. For number 2A is 0.71. For number 2B is 0.1698. Very good, Blue. How about you there? What is next, Orange? We'll have about sample size. What is sample size? A sample size is part of the population chosen for a survey, research, or experiment. It is represented by n. What is the formula for that? N equals 4 times the square of the quantity, the critical value multiplied to the standard deviation all over L. or it could be n equals 4 times p times q times the square of the quantity of the critical value z all over L. It is derived from the formula of finding the length of interval. You are correct, Blue. Here are some examples of finding sample size. Example number 1. Lumen wants to know with 98% confidence the proportion of households who like to use detergent X. A previous survey showed that 42% like to use detergent X, an interval length of 5%. What sample size does Mary need? For the solution, we use the formula n equals 4pq times the square of the quantity, the critical value z, all over L. So our given P equals 42 and our Q is 0.58. Our critical value is 2.33 since the given confidence is 98%. And our L is 0.05 represented by 5% interval. Using the formula, n equals 4 times 0.42 times 0.58 times the quantity square of 2.33 divided by 0.05. So, the product of these three numbers for 4.42 and 0.58 is 0.9744. And the quotient of 2.33 over 0.05 is 46.6. Then quantity square. The square of 46.6 is 2171.56 and it will be multiplied to 0.9744. And using our calculator, our n is 2115.87 or 2116. Thus, she needs 216 housewives to enter view. Example number 2. In previous study, people do physical exercise in a gymnasium with a mean of 30 minutes and a standard deviation of 6 minutes. A PE major wants to estimate the true mean length of 2.4 minutes adopting 99% confidence interval. How many respondents does he need? So the formula to be used will be n equals 4 times the square of the quantity, the critical value multiplied by the standard deviation or over L. So our critical value is 2.575 because of the given confidence level of 99%. And then a standard deviation is 6 and the length is 2.4. Substitute into the formula n equals 4, 2.575 times 6 over 2.4, then the quantity square. So 2.575 times 6, when we multiply that to the answer is 15.45. And 15.45 divided by 2.4, we have here 6.4375. And 6.4375 square is 41.4414. So 4 times 41.4414 is 100 and is 165.76 or 165. Hence, the PE major needs 165 respondents. I got it, Orange. I believe you are ready for the last activity. What is the last activity, Orange? It is a problem-solving activity. Here is the last activity. Read the problem below and answer the questions that follow. In Barangay Cabancalan, Lando wants to estimate the mean weight, mu, in kilograms of all 6-year-old children to be included in feeding program. He wants to be 99% confident that the estimate is accurate to within the length of interval of 0.6 kilograms. Suppose from a previous study the standard deviation of the weights of the target population was 0.5 kilograms. What is the sample size should be? You have 5 minutes to answer.
A few moments later.
Let us now have the answers. What is your answer, Blue? My answer is 18. Is that correct, Orange? You are correct, Blue. Landon needs 18 samples. If you have some suggestions, comments, and queries regarding our topic, just give your thoughts under comment section. Thank you very much. See you next topic.